Find the vertical asymptotes of this given function, which is y equal to x squared plus 1 divided by 5x minus 2x squared. So in this example, we need to find the vertical asymptote of this given rational function, right? So how can we do that? If we have the rational function and if we are interested in finding the vertical asymptote of that, what we can do here is first figure out what are the possible vertical asymptotes. So what are the possible locations where you can have the vertical asymptote? We can look into that. Well, that can be just done by just looking into where the denominator is 0. So the location where the denominator is 0, right? So corresponding to that, whatever the vertical line passes through, then that can be the vertical asymptote. First of all, that's why let's just try to figure out what are the possible vertical asymptote. So like I said earlier, to check that, we can just try to see where the denominator is 0. We don't know that directly here, so let's just set it equal to 0 and then solve for x. Okay, so how can we solve this for x? This is just the quadratic equation. Either if you want, you are interested in using the quadratic formula, you can do that, right? But if you just want to factor it out up to the linear factor, let's try that. So if I take x out as a common factor, I can clearly see here 5 will be the remainder on the first term, and on the second term I will have 2 times x as the remainder, right? So that's how I can factor out this expression over here on the left hand side. Now set that is equal to 0. Now when I do that, I can just solve for x. I will get by using the 0 property. Then from here I will have x equal to 0, right? Or 5 minus 2x is equal to 0. So this is already a solution. I don't have to do anything over here, but this is kind of a linear equation. I just need to solve for x. So let's do that. So how can I do it? Let's subtract 5 on the both sides. So I get negative 2x is equal to negative 5, right? And then I can divide by negative 2 on the both sides. So when I do that, I will get negative 5 over negative 2, and which is actually x equal to 5 over 2. So what I get here is x equal to 0 and x equal to 5 over 2. At these two locations, the denominator is 0. That means the possible vertical asymptotes are the vertical line passes through that location. That means x equal to 0 and x equal to 5 over 2 could be the vertical asymptote. Do I know right now these are the vertical asymptote? I don't know. How can I confirm that? To confirm if these two are the vertical asymptote, what we can just do is now check at these two numbers, that means at x equal to 0 and at x equal to 5 over 2, if the numerator is 0. So how can I do that? Just replace x by 0 to the top. So replace x by 0, so we get 0 square plus 1, right? When I plug that in on this numerator, and 0 square is 0, 0 plus 1 will be just 1, and that is definitely not 0, right? So similarly, if I plug 5 over 2 in to the numerator over here, again I'll have 5 over 2 square of that plus 1, and this quantity is also not equal to 0. So what do we get here? We figure out that on this real set of real numbers, let's say from negative infinity to positive infinity, at let's say 0 and at 5 over 2, it turns out that at these two locations the denominator of this rational function is 0 but the numerator is not. And if that happens, then we can clearly say that the x equal to 0 and x equal to 5 over 2 are your vertical asymptotes, the equation of the vertical asymptote. Okay, so these are equations of the vertical asymptote. Okay, so for example, on this particular let's say if you have a similar type of rational function, but let's say it turns out that at x equal to 0 the denominator was 0, obviously we solved for that, right? But if the numerator is not, then that may not be your vertical asymptote. On this case, both of these locations at x equal to 0 and x equal to 5 over 2, the denominator was 0, numerator was not, right? So on that case, definitely both of these are equation of the vertical asymptote.